Let's suppose that a projectile is shot with an upward velocity of 65 meters per second. The height of the projectile will be given by the following equation: h equals 65t minus 5t squared, and we wish to find the values of t, the values of time, for which the height of the projectile happens to be 30 meters above the ground. So in the illustration below you can see this projectile kind of taking off, and since it's going fast to begin with, 65 meters per second, it's going to go above 30 meters relatively soon to the beginning of being fired, and then of course due to gravity it's going to continue along an upward path until it starts to reach its peak, and then it'll start to come downwards. So there'll be another time when it hits 30, somewhat after the first time that it hit 30. Right? So it's going to hit 30 twice, once on the way up and then once on the way down. And this problem is asking for those times. What are those times? So notice that the givens in this problem were the equation for the height, where height equals 65t minus 5t squared, and we were also given that the height is equal to 30. And then what do we want? We want to find the time at which this happens. So, taking the equation, we know that h equals 30, so I'll substitute that into the given equation and say 30. And then that's going to be equal to 65t minus 5t squared. Minus 5t squared. And now the goal is to try to figure out what t is. So as a first initial step, I'm going to move by the addition property. I'm going to add 5t squared and subtract 65t from both sides of the equation. Plus 5t squared minus 65t. So that way on the left hand side I end up having 5t squared minus 65t plus 30, and on the right hand side, thanks to the cancellations, we'll end up being left with 0. So this puts us into a situation that's quadratic, so we can use a quadratic formula to be able to solve this. There are some extra techniques you could do that are a little bit more advanced, like dividing by 5 in order to make the numbers more manageable, but since we're going to round anyway and use a calculator, let's just deal with it the way it looks right now. So a little technique for dealing with the quadratic formula is to notice that this right here has a coefficient a coefficient b, and a coefficient c that needs to be placed into the quadratic formula. So if we isolate those variables and look at them specifically, a equals 5, b equals negative 65, and c equals 30. Okay, I encourage you to pause the video and see if you can find the solutions on your own, but assuming that you've already tried this, just to make sure that we get the right answers, let me do it on here, and then you'll see if you got the same answers as I did. So when I progress through this, the first thing I always go for is a d, which is the discriminant, you might remember. Now the calculation for the discriminant is b squared minus 4 times a times c. So in this instance, the b is negative 65 minus 4 times a, which is 5, and then c, which is 30. So if we simply calculate what this is, probably with a calculator, but by hand if you wish, you will end up getting 3,625. Now that's not the end of the problem, that's just the discriminant. In the quadratic formula, that's the piece that's underneath the square root. So, in order to find the actual solutions for the quadratic formula or quadratic equation here, we'd find t is equal to negative b plus or minus the square root of d of the b squared minus 4ac all over 2 times a, or 2 times 5, which is 10. So in other words, you'd end up getting negative of negative 65, or opposite of negative 65. So 65 plus or minus the radical of 3,625 all over 10. And those are the two solutions. Now a calculation with a calculator would yield that these two solutions happen to be, one is that t is equal to 12.5 0.52 seconds, which would be what you would get if you used the plus sign. And then on the minus sign, when you subtract, the solution you should end up getting is 0.48 seconds. So those are the two solutions to this particular word problem, and that means that the icon, or that the projectile here at x equals, or at t equals 0.48 would reach 30 meters on its way up, and then on the way down at t equals 12.52 it would then hit 30 meters on its way down.